Hello everyone, in this video we'll be discussing the distance form or the parametric form or the symmetric form of a straight line. Now, how do we get started with this? First of all, you need to understand that we have already discussed and studied the standard form ax plus by plus c is equals to 0. We have studied how to convert that standard form into slope form y is equals to mx plus c. And then we have studied the intercept form as well, which is x upon a plus y upon b is equal to 1. Now, apart from that, we have also discussed the normal form x cos alpha plus y sin alpha is equal to p. Now, out of all these forms, do we still really need another form of a straight line? Yes, there is one more form which actually helps us a lot in solving a lot of problems with a lot more efficacy. Now, how does that happen? Let's have a look at this video through which we'll understand it more clearly. Let's take that there is a straight line which passes through a point x1 comma y1. So there is this straight line and these are your coordinate axis. This is your x-axis, that's your y-axis. And this straight line over here, let's say, passes through a fixed point. Let's call that x1 comma y1. Can I do so or can I say so? Now, apart from that, one more thing which I am already aware of is that this straight line makes an angle theta with the positive direction of x-axis in the anti-clockwise direction. Now, we all know how to write the equation of this straight line, right? It passes through a point, so the coordinates of that point are given. Along with that, the angle made by this line with the positive x-axis is also known by us. Now, how do I solve it further? I hope we know that we can write the equation of the straight line as y minus y1 upon x minus x1 is equals to tan theta, right? Apart from this, how do I convert this form into the symmetric form or the parametric form or the distance form, and what is the advantage of having that? Let's discuss that. Can I write this tan theta as sin theta upon cos theta? Not just that, I hope you all know that x minus x1 can be taken to the other side, sin theta can be brought to this side. So this form over here, x minus x1 can be taken to this side, which can be written as this x minus x1 upon cos theta, and that sin theta can be brought here and written as y minus y1 upon sin theta. Now, some of you might wonder, why did I do that and what is the need of doing it, or why do we actually do it? So let's try and answer that question through this simple method. Let's say that on this straight line, there is a point r distance away from it. Now, what is the meaning of it? Say that if I stretch this line a little further and r distance away from this point, let's say there is another point r distance away from this point x1 comma y1, right? So this point is here is r. Now, this point, this distance is r, and that point over here is x comma y. Now, we all know this very clearly, students, that if I draw a perpendicular from here on the x-axis and if I draw a line parallel to the x-axis like this, so I need not tell you that this distance is going to be y minus y1, because this entire distance over here is y, and this distance over here is y1 because this point is y1, y coordinate, right? So this distance over here, distance, right, is going to be y minus y1. Similarly, can I not say that this entire distance is going to be x and this distance is going to be x1, although I'm supposed to put a mod over it, but in terms of this particular distance, can I not say directly that this distance is going to be x minus x1? So I'll be taking this distance as x minus x1. Now, by using this symmetry, can I also not say that if these two lines are parallel, this line is behaving as a transversal? So if this angle happens to be theta, this angle here also going to be the angle theta, right? I hope you all can see it very clearly. I hope you are able to understand all of this. Now, why did I do all this? Try and understand. Can I not say that tan theta is going to be y minus y1 upon x minus x1? Not just that, if this distance, which is the hypotenuse of this triangle, can I say that cos theta is going to be x minus x1 upon r, and sin theta can be said to be y minus y1 upon r, which means I'm drawing two more conclusions, that cos theta is going to be base upon hypotenuse, which is x minus x1 upon r, and sin theta is going to be perpendicular upon hypotenuse, which is going to be y minus y1 upon r, right? I hope this part is very well understood by all the participants. Now, what do I do next? Please understand, if I just do one more thing. Say, if I take this r on the other side and cos theta on the other side, can I say x minus x1 upon cos theta is going to be r? I repeat, x minus x1 upon cos theta is going to be r. Similarly, if I take this r also here and sin theta here, can I not say that y minus y1 upon sin theta is also going to be r? Which means y minus y1 upon sin theta, x minus x1 on cos theta is going to be equal to r. That's exactly is said to be or called the symmetric form or the parametric form or the distance form of a straight line. Now, what is the advantage of this? Now, I mean, why should we have this? We are already having a lot of equations, right? We are already having a lot of forms. Now, why are we introducing another form, another version? Some of you might have noticed or understood that while deriving this form, I have used a term r. And some of you must have interpreted or comprehended or concluded that yes, this r is going to help us a lot. In what sense, in what way? Let us try and understand through some more examples, through some questions. But before I proceed further, are you not realizing that if I were to say that there is a straight line whose slope is given and there is a point on this line x1 comma y1, and if I were to ask you that find the coordinates of the point which is r distance away from this point x1 comma y1, by using this formula, will you not be able to identify or determine those points x comma y? Try and understand. All I'm trying to make you understand is that if I use this particular formula, if I use this particular equation, I'll say that x is going to be r cos theta plus x1. So what I'm saying is x is going to be r cos theta plus x1. Similarly, y is going to be r sin theta plus y1. I hope you can draw this deduction that r times sin theta plus y1 is going to be the value of y. So y is going to be r sin theta plus y1. This is what I hope you are understanding and realizing. This is nothing but what? The coordinates of the point x comma y, which is r distance away from the point x1 comma y1 on the line which is having its slope as tan theta. I hope you're realizing the importance of this. But some of you might have noticed that there is a catch in this statement. There is a loophole in this statement. Now, what is that loophole? Please try and understand. The problem here is that so far, while deriving this, while deriving this deduction, I have taken r positively. Rather, to be more precise, I have taken this point x comma y on the upper side or on the right side of this x1 comma y1. Are you not thinking that this r could have been on the other side as well? That's also a possibility, right? Now, what I'm trying to make you understand is that if I move r distance upward or rightward from the x1 comma y1, I would have used or taken r as positively. But had I taken x1 comma y1, x comma y on the left side or the downward side of x1 comma y1, I should have taken r as negatively. So there are two possibilities. I hope you're realizing it very clearly that there's this point x1 comma y1, and when somebody says that there is a point r distance away from x1 comma y1 on this line, now two possibilities arise in this case. There is ambiguity, right? There is some vagueness in this statement. Now, what is that vagueness? That r distance you can travel either on the upward side or on the downward side, right? So let's say if I were to say that there is a point 2 unit distance away from this point. So there are two possibilities. You can take r as plus 2 or you can take r as minus 2. So if it is not mentioned or specified clearly, I am supposed to consider both of the values of r, that is plus 2 and minus 2 if it is given to be 2. So I hope you are understanding that catch, that if simply it is said that it is r distance away, I am supposed to take two values of r, plus r and minus r. I hope you are realizing the catch here. I hope this part is very well understood. And if that part is understood by all of you, that what is the symmetric form or the distance form or the parametric form of a line, let's understand it with the help of some more examples. And through those examples, I'll try and make you understand that why is it another very much needed form of a line. Trust me, all the questions which we'll be doing now can be done through the conventional methods, through the traditional, forms of the straight line as well. There is nothing wrong in that. But what you'll observe is that efficacy, efficiency, or the productiveness of this particular form is way more than all those forms. You'll see it by yourself, you'll witness it by yourself. So let's look at certain questions and understand that what is the point here. So I hope we have already seen that a point can be taken as x1 plus r cos theta or x1 minus r cos theta, depending that whether it is above or below that x1 comma y1. Similarly, y coordinate can be y1 plus r sin theta or y1 minus r sin theta. Along with that, yes, there is this point that yes, it could be plus r cos theta plus minus, it could be plus r cos theta plus r sin theta or minus r cos theta minus r sin theta from x1 y1, depending above or below. Let's look at this question to understand it better. I hope this question is very well visible to you all. So what does it say? Slope of a straight line. I'm just trying to give you the very basic example through which you can understand the symmetric form or the parametric form, or how is it utilized. So what are we told? The slope of a straight line through 3, 2. So there is a point on this straight line which is said to be 3, 2, right? And the slope of this straight line. Now what do you mean by slope of this straight line? Which means I'm given tan theta that happens to be 3/4. Now if somebody says that tan theta is 3/4, can I say cos theta and sin theta are going to be what? So 3, 4, 5, that's Pythagorean triplet, right? So sin theta can be taken as perpendicular upon hypotenuse, which is 5, and cos theta can be taken as base upon hypotenuse, which is going to be 4/5. I hope this part is very well understood by all of you. Now, apart from that, if I were to write the parametric form, which I don't need, please understand what is the question. Let's look at the question. Find the coordinates of the points on the line that are 5 units away from A. Now, they have already saying 5 units away from. Now, I hope you are realizing if they are simply mentioning that they are 5 units away, so there are two possibilities, either upward or downward. So if I go upward, I'll be using +5. If I go downward, I'll be using -5. So if this is 3, 2, another point which is 5 units away from it could be x1, which is 3, plus or minus depending upward or downward. I'm using both the points here only. I'm just going to write the combined or the clubbed equation and then I'll segregate it. R cos theta. Now what is R? R is this 5 units, right? So that's the distance over here. So 5 cos theta. That is going to be the x coordinate. And what about the y coordinate? It is going to be y1, which is 2, plus minus r, which is 5 sin theta. I hope you are realizing this very clearly. Now, if I were to write the final answer to this question, do you not think that, I hope you all can see it very clearly, 5 cos theta, we know the value of 5 cos theta, 5 cos theta is 4, and we know the value of 5 sin theta, which is 3. So I can substitute these values directly over here. So my answer will be 3 plus minus 5 cos theta we have already seen as 4, comma 2 plus minus 5 sin theta we have already seen as 3. So that is 2 plus minus 3. Apart from this, if I simplify this, I'll be getting 2 coordinates because 3, 2 will have 5 distance like this, or another 5 unit distance can be traveled in the downward direction as well. So two answers are going to be 3 plus 4, 7, 2 plus 3, 5. So one of the coordinates could be 7, 5, or the answer could have been 3 minus 4, which is -1, 2 minus 3, that is also -1. So the two answers are going to be 7, 5 or -1, -1. So I hope you're realizing how are we solving these category of questions. Let's have a look at another question to understand it better. This particular question which says that a line joining the points A, 2, 0, right? So you have this point A, 2, 0. Always remember, if it is in your hand that you are able to draw it more precisely, more accurately, rather what I'm trying to say is that as per the coordinate, Cartesian system, so try and draw it as accurate, as precise as possible. That will help you in solving the problems in a more clearer manner. So let's say there is a point A, 2, 0, and there is another point B, 3, 1. So what I'll say is that B might lie somewhere here. So I'll call it 3, 1, right? Now, what do they say? That this line, AB is rotated about A. So the point A is fixed here. This point A is fixed over here. And this is rotated about A in the anti-clockwise direction through an angle of 15 degree. So this point over here is rotated by 15 degree. So this angle over here is basically nothing but 15 degree. I hope you can see this very clearly. Now, find the equation of the line in the new position. So find the equation of the line in the new position. So first of all, let's say that this point is C, which is also said by the question that if B goes to C in the new position, what will be the coordinates of C? So you need to find two things. A, coordinates of C. B, equation of the line AC. Now, some of you might wonder, who have studied the chapter complex numbers, would be desperately wanting to say that, sir, use rotation formula or the Coney method. Basically, both are the same versions basically. So try and use that and you'll get the answer very quickly. Trust me, in this particular question, it will make it even, more cumbersome, more troublesome, more, problematic. Now, what do I mean by that? Please understand, in this particular question, can I find this particular angle? What is it? It is nothing but what? Inclination of this line AB with the positive x-axis. So if I were to talk about the inclination, let's find the tan theta here, which is the slope of the line AB, which is y2 minus y1. So 1 minus 0 is 1 and 3 minus 2 is also 1. So tan theta is basically turning out to be 1. Now if tan theta is 1, I hope you are realizing that in a very simple world, I'll say that theta is going to be pi by 4 or 45 degree. I hope you're realizing it very clearly. So this angle over here is basically nothing but 45 degree. What you all must have noticed is that, sir, if you are rotating AB, by keeping A fixed and B is becoming C, so technically this distance AB is not getting changed. So if AB and AC were to be found out, they'll have the same length. I hope I need not explain this part. Why did I say so? Can you help me in finding first of all AB by using the distance formula? I hope you'll say that 3 minus 2 is 1, 1 minus 0 is 1, so 1 square plus 1 square, which is 2, so this is going to be square root of 2. That's the distance AB. The same distance will be held by AC. Can I say so? That AB and AC are going to be of equal length. Apart from this, what I know so far is that if this was 45 degree, and this was rotated further by 15 degrees in anti-clockwise direction, this angle now is going to be 45 plus 15 is going to be nothing but this angle over here is going to be a 60 degree angle. Now, why did I do all this? Why are we doing all this? What is the point of doing all this? Some of you might have noticed that again, there is a point x1, y1 which is 2, 0. There is an angle theta which is 60 degree. There is a distance r which is root 2. And I need to find a point C. No Coney method, no rotation formula, nothing is required at all. All you need to use it, the symmetric form or the parametric form or the distance form of the straight line. Some of you might have already gotten this while I was explaining or reading out this question, right? So how do I do this? I hope it's very simple for us to write the coordinates of C. And there is no confusion that whether it will be plus r or minus r. Since C is our way, we can very easily deduce it is going to be plus r. Plus r means plus root 2. I'll not be using minus root 2. I hope you're realizing why. So with that, I'll be using x1, which is 2, plus r cos theta. What is cos theta? That is cos 60 degree and r is root 2. So that's r which is root 2 and cos 60 degree. I hope you are realizing cos 60 degree is 1 by root 2, which is, 1 by 2. So root 2 by 2 is 1 by root 2. That's what I was saying or mentioning. Similarly, I hope this part is very well understood by you. Similarly, I'll be writing the y coordinate is y1, which is 0 plus r sin theta. What is r? Root 2. And sin theta is sin 60. Sin 60 is root 3 by 2. So r was root 2 and this is root 3 by 2. So I hope there is no confusion so far on this. So if I were to simplify this or write the final answer, C, that will be students how much or what will it be? Root 2 by 2, that is 1 by root 2. So this is 2 plus 1 by root 2. Similarly, this point over here is going to be either you call it root 6 by 2 or I may call it root 3 by 2, or some of you would like to call it root 3 by root 2. So that's what we have done over here. This is 2 and this is small bracket. So this is how you could find the coordinates of C. Now there is another question. They had mentioned that find the equation of the line in the new position. So if B goes to C in the new position, what is the equation of this line AC? I hope that's again a very simple task. You have two choices. Either you write now the parametric form or the symmetric form or the standard slope form or whichever form. I think the 2-point form is more suitable. Or if you already know the slope, Even one point form is more suitable because that will make your calculation a little more complicated. So equation of the straight line is being written over here. I hope this part is very well visible to you all. So equation of this line is going to be y minus y1, which is y minus 0 upon x minus x1, which is x minus 2, is equal to tan theta. In theta now, the slope of the line will be tan 60, and tan 60 we all know is under root 3. I hope you all are comfortably understanding this part. Now, I need not tell you what is going to be the answer. So it is going to be y is equals to root 3x minus 2 root 3. Either this could be given in the options, or you simply shift all of this on the y on the right hand side, and that's how you get the standard form of the equation of the straight line. So this is how you could answer this question, and I hope you're realizing instead of Coney method or rotation formula, this can also be used in this category or kind of question. Well, there is a lot, there is a huge variety of questions based on this particular concept. That is, you can use this concept in a lot of questions and you can get the answers very easily, very effectively, very quickly. Look at this particular question. Find the direction in which a straight line must be drawn. Now, what do they mean by direction? Direction means the inclination, the theta, the slope, right? I hope you're understanding. So we need to find slope somehow. Must be drawn through the point 1, 2. So I hope you're realizing x1, y1 are going to be 1, 2 in this case, so that its point of intersection with the line x plus y is equals to 4. So there is another line x plus y is equals to 4 with that line. The point of intersection of that line which is asked may be at a distance of root 6 by 3 from this point. Now again, they haven't mentioned in which direction, in the above or in the below, in the right or in the left. So if it is not mentioned, it is up to me to consider both of the possibilities. I hope you're realizing why. Now, let's try and explore both of the possibilities, or it is basically going to happen eventually, so you need not bother about that. Let's try and focus on the equation of the straight line. So I hope I need not tell you. If I assume that the line makes an angle theta with the positive x-axis in the anti-clockwise direction, and if it is passing through 1, 2, the symmetric form helps us in understanding that any point lying on this line are a distance away from it. So let's say this point here is r distance away from it. So can I write the coordinates of that point? So let's say if this was A and this point over here is B. So can I write the coordinates of point B with respect to what all I'm given? So B will be nothing but what, students? B will have coordinates as x1 plus r cos theta. Although r should be plus minus, which I'll handle later, but as of now I'm considering it to be plus r cos theta, and y1 which is going to be 2 plus r sin theta. So r could be either plus or minus, positive or negative, that will be discussed later, but this is going to be the general coordinates of that point B. So I hope there is no confusion on this. Why did I take this? Why did I do this? Now, what additional data or information I'm given so far? What I'm told is that this particular line, I hope you're realizing, we are also given the value of r. R was root 6 by 3. So if r was root 6 by 3, I hope root 6 by 3 can be taken as root 6 is root 3 into root 2 by 3, which is root 2 by root 3. So root 6 by 3 can also be taken as, I hope you're realizing, root 6 by root 3, right? So that can be taken as root 2 by root 3. So r I'm taking as root 2 by root 3. I hope that's not a problem at all. So this r here can be replaced by root 2 by root 3, which I forgot noticing. So this should be root 2 by root 3 cos theta. Here it should be 2 plus root 2 by root 3. I hope no confusion so far. Let's proceed further. What I know now is that this line AB intersects this line x plus y is equals to 4 at that point B, because that point B is root 2 by root 3 distance away from A. That's exactly what we were given. So there is another point which I'm not drawing accurately, but let's say this line happens to be x plus y is equal to 4. I hope most of you must have understood that what are we going to do next. I hope all of you are realizing that if this point B happens to lie on the line x plus y is equals to 4, it must satisfy this equation. So I hope we all are understanding what is going to be the approach. So B, which is going to be, x is going to be 1 plus root 2 by root 3 cos theta. So that is 1 plus root 2 by root 3 cos theta plus y, which is going to be 2 plus root 2 by root 3 sin theta. is equal to 4, right? I hope you can see 1 plus 2 is 3, 4 minus 3 is going to be, 4 minus 3 is going to be, students, 1, right? I hope you can see it very clearly. Apart from this, what else can I do? I hope root 2 by root 3, root 2 by root 3 can be taken common and taken on the other side. So from here, can I say that root 2 by root 3 can be taken away from here and it can be written as, it was root 2 by root 3, right? So it will be root 3 by root 2. I hope no confusion so far. Now, how do we solve this category of questions? Now you have two choices, either square both the sides or use cos a plus b or use sin a plus b. Rather cos a plus b, I'll say cos a minus b it will become. How? Please understand. What I'm doing is I'm multiplying both these sides by 1 by root 2. I'm multiplying both these sides by 1 by root 2. So I'm multiplying this side by 1 by root 2. I'm multiplying this side also by 1 by root 2. I'm multiplying this side also by 1 by root 2. Both these sides means left hand side and right hand side. So I hope you are aware of it, that 1 by root 2 can be taken as cos pi by 4, cos 45 degree. This 1 by root 2 can be taken as sin pi by 4, sin 45 degree. And this is root 3 by 2, right? So this here is going to be cos pi by 4, cos theta plus sin theta, sin pi by 4, or whatever you wish to write it. This is sin pi by 4 and that is root 3 by 2 over here. I hope there is no confusion on this. Now what do I do further or next? Cos a cos b plus sin a sin b. Cos a cos b, theta I'm taking as a. So LHS is going to be cos theta minus pi by 4 because it is cos a minus b, and on the right hand side it is root 3 by 2. So root 3 by 2 in cos is going to be 30 degree. I hope you are realizing it very clearly. So cos 30 degree, right? Cos, either you write it as 30 degree or pi by 6. I hope there is no confusion on this. Now what I do next is, I hope you know that if cos theta is equals to cos alpha, the general solution is theta is equals to 2n pi plus minus alpha. So the general solution will be theta minus pi by 4 is equals to 2n pi plus minus pi by 6, right? Apart from this, what we know is that if you are talking about the slope of a line, it is always, between 0 to pi, because this line will always, I hope I have drawn it from origin, it doesn't matter, but this theta cannot go beyond pi. When it comes to the slope of a line, the inclination of the line cannot go beyond pi. So it always lies between 0 to pi. So I need to find the theta. Theta is the inclination or the direction or the slope of the line. Basically slope is tan theta. So I need to ensure that whatever values of n I try over here, I should ensure that theta should lie between 0 to pi. So I'll try and do it. First of all, I'll try the value of n as 0 because that is the most simple one I'm seeing. So theta is going to be, first of all, I'm writing it as 2n pi plus minus pi by 6 plus pi by 4, right? So when I try n to be 0, so this whole expression becomes 0. I get two choices, pi by 4 plus pi by 6 and pi by 4 minus pi by 6. So I'll try pi by 4 plus pi by 6 first, and then I'll try pi by 4 minus pi by 6 later. Now, pi by 4 plus pi by 6, what do I get? I hope you can see it very clearly. Pi by 4 plus pi by 6, if I simply, take the LCM, it is going to be 3 pi by 12 and it will be 2 pi by 12. I hope you can see it very clearly. So 3 pi plus 2 pi, which is going to be 5 pi by 12. I hope I need not tell you this. This is going to be 3 pi by 12, 2 pi by 12. So 3 pi minus pi is going to be pi. So the other answer is going to be pi by 12. So I've gotten two answers, pi by 12 and 5 pi by 12. Now some of you might wonder, why did I get two answers? Some of you might have understood it. Yes, there are going to be two answers. I'll try and explain it why and how. Basically the answer is isosceles triangle, or the answer could be, see, what I'm trying to make you understand is that there is this point 1 comma 2. There is this fixed line x plus y is equals to 4, right? I'll just try and explain why did we get two answers, right? See, so 1 comma 2, through 1 comma 2, I can have two straight lines. Through 1 comma 2, I can have two straight lines from which this line will be root 6 by 3 distance away. I hope you can see that this distance could have been root 6 by 3 or this distance could have been root 6 by 3. So one of the lines can have the slope 5 pi by 12. The other line can have the slope pi by 12. That's why we have gotten two answers. I hope you are very easily and comfortably able to understand why are we getting these answers, how are we getting these answers, and how effectively we are using these methods, the symmetric form or the parametric form or the distance form of a straight line. Let's get more clarity. Let's delve a little more deeper into this particular concept and understand how is this concept can be utilized in this different category of set of questions. A line through 2, 3 makes an angle 3 pi by 4 with the negative direction of x-axis. Please understand, you have this x-axis and y-axis. So the line passes through 2, 3. Let's say this is the point 2, 3, but this makes an angle 3 pi by 4. So I'm really sorry. If this makes an angle 3 pi by 4 with the negative direction of x-axis, this could have been drawn like this. Please understand, if this is the point 2, 3, I'm just drawing it randomly over here. So if this point is 2, 3, it is making an angle 3 pi by 4 with the negative direction of x-axis. I hope you can see it very clearly. So if this angle is drawn with the negative direction of x-axis, the angle made by this line with the positive direction of x-axis is going to be pi by 4. 3 pi by 4 plus pi by 4 is basically pi, right? Basically pi minus 3 pi by 4 I have done. So I can say this is going to be pi by 4, or we all know that this is going to be 135 degree. This has to be 45 degree, whatever you wish to use. Now, find the length of the line segment cuts off between 2, 3 and the line x plus y minus 7. Again, let's say there is this line x plus y minus 7. Now, let's say I impose another constraint on this. Some of you might say, sir, you need not use symmetric form or the parametric form or the distance form, because what you can do is you can write the equation of this straight line, because a point and its slope is its inclination is given to you. You can write the equation of this straight line. You can find the point of intersection of both of the lines by solving both of the lines together, and then you can write the answer. That's how easy it is. I totally get this. Yes, this is how easy it is. But if I were to impose you a condition on this question that without finding the coordinates of the point, I mean, without finding this point of intersection, can you still do it? Now that's a challenge, and some of you might think that yes, it is possible, because we know the symmetric form or the parametric form or the distance form of this straight line. So how do I do that, or how do I achieve it? Please understand. Again, what am I asked? See, so far what I know is that this point is going to be, on the right side or on the upside. Even if I don't know it, I'll take it as r. So I'll take this distance, this particular distance as r, right? So this distance, the distance between these 2 points, I'm assuming to be r. I hope we can do that. It is very properly visible and understood by everyone. Now, can you help me with the coordinates of this point? We all know how do we write it. So it is going to be 2, which is x1, plus r, which I don't know, cos pi by 4. Cos pi by 4 is going to be 1 by root 2. Similarly, y1, which is 3, plus r sine pi by 4, which is again going to be 1 by root 2. So this is going to be the coordinates of this point. Now I haven't found the coordinates of this point, and what I know is that this point again happens to lie on this line, which means it should eventually satisfy this equation of the line, and that's how, by having this equation, I can get the value of r. I hope you're realizing this is also one of the most effective methods we can use. So by having this particular idea and this particular question, the answer is going to be, I'll put x as 2 plus r by root 2. So this is going to be 2 plus r by root 2 plus y as 3 plus r by root 2 minus 7 is equal to 0. So 7 can be taken on the other side. 3 plus 2 is going to be 5. 7 minus 5 is going to be 2. So I'll have 2 r by root 2 here. I hope you can see it very clearly. So this 2 gets cancelled by this 2. I hope I have done the calculation right. Yes. So the value of r, the distance, is going to be root 2. This is how easy these questions are. So this is exactly, I think, what we were asked. Yes, find the length of the line segment. So this line segment cut off between 2, 3 and this point of intersection is going to be root 2. So I hope you're realizing questions are simple, questions are easy. If you know the concept, you can crack them very easily. Let's delve deeper and understand this concept with one more example. Trust me, all of the questions which we are discussing right now, or the last 2-3 questions, were with the change of a little bit of data, were verbatim, were exactly asked by JEE Mains in the previous years, right? In the recent years, in the latest years as well. So find the distance of the point 2, 3 from this line measured along the line. Now that's a different category of question. How do we solve this kind of questions? Please understand, what are they trying to say? distance of the point 2 comma 3 from this line. Now, had they not mentioned anything else apart from this part, that distance of this point 2 comma 3 from this line, I would have answered that all you need to find is the perpendicular distance of a point from a line, and the formula is already there, ax1y plus b1, sorry, ax1 plus by1 plus c upon under root over a square plus b square. Basically, modulus is what you put in the numerator so that you can find the distance as positively, because distances are always positive. I hope you're understanding. Power of a point, modulus of the power of a point divided by under root over a square plus b square is the distance formula. But that is not what is going to work here. Why? Because that is not what they are asking. What you need to understand is distance of this point from this line measured along the line. Measured along the line means that is not the perpendicular distance of 2 comma 3 from that line. Please understand, there is this point 2 comma 3, right? There is this point 2 comma 3 like this. I'm just drawing it all randomly. And there is this line, let's say 2x minus 3y plus 9 is equal to 0. Now, some of you might think that this is what they are asking. Yes, if nothing else is mentioned, we always take the distance to be perpendicular. So, this is what you were supposed to do, but they have additionally specified something else, which is what you need to consider, that there is another line, which is 2x minus 2y plus 5. So, let's say the another line is 2x minus 2y plus 5 is equal to 0. So, what you now need to do is, you need to measure the distance of this point from this line along this line, which means you need to draw a line parallel to this line passing through this point, and that distance is what you need to figure out. And yes, this distance, this angle over here need not be a right angle. I hope you're understanding. This angle could be any angle, and that's why we cannot use that distance formula. So what do? Please understand, nothing much is needed to be done if you know the parametric form or the symmetric form or the distance form of a straight line. I'm constantly repeating this thing. How do we use that? Please understand that if these two lines are parallel, what do we know? If these two lines are parallel, their slopes are going to be same, their inclination with the positive x-axis will be same. So, can I find the slope of this line? I hope to find the slope of a line. What we know is, from the standard form, I'll take the ratio of their x and y coefficients and I take the negative of that. So, the value is going to be 2 upon minus 2 and negative of it, right? So, this is going to be 1. 1 clearly helps us in understanding that the angle is going to be, I hope you're realizing, the angle is going to be, the theta of this line is going to be pi by 4. And that theta will remain same for this line as well. If pi by 4 is the inclination of this line, pi by 4 will be inclination of this line as well. I hope no confusion is there so far. So, theta is what we already know. Can I say that the distance between these 2 points can be taken as r, which is exactly what we are trying to figure out? So, if I know r, if I know theta, can I not write the coordinates of this point? This point will have the coordinates as x1 plus r cos theta. R is r, which is what we are trying to find out. Cos theta is pi, cos pi by 4, which is 1 by root 2. Similarly, 3, which is y1 plus r sin theta, which is again going to be r by root 2. So, I hope you are comfortably understanding what I have done so far. Now, the next part will make me understand that the same logic needs to be applied time and again, that if this point lies on this line, it must satisfy the equation of the line. That's what I'll do. So, 2x means 2 times 2 plus r by root 2, right? Minus 3y, that is 3 times 3 plus r by root 2 plus 9 is equal to 0. So, by having this equation, I can very clearly see 2 into 2 is 4, 3 into 3 is minus 9 and plus 9 I'm already having over here. Apart from that, the variable things are going to be 2r by root 2 and that is minus 3r by root 2 is equal to 0. I hope I've done nothing wrong in terms of calculation. 4 minus 9 plus 9, that is 2r by root 2, that is minus 3r by root 2. Yes, we are going great. Now further, what I'll do is, this 9 is cancelled. 2r by root 2 minus 3r by root 2 is minus r by root 2. That can be taken on the other side, which is r by root 2. And here I'm left with 4. No confusion so far, students. So finally, r is going to be 4 root 2. What was r? Distance of this point from this line along with this line. The answer is going to be 4. I'm really sorry. The answer is going to be 4 root 2, right? So, root 2, 4. I have written it like this. I hope that's very easily understood by all of you. So I hope the question was simple, the language was simple, and you must have understood how did we use the parametric form in different cases, in different scenarios. So far what we have done is all the forms of these straight lines. This concept can be consolidated with more examples, with more illustrations. So in the very next lecture, we can have previous year's questions from mains and advanced based on this concept to have more clarity on this. With that, let's call it a day. Thank you so much. You have been a great audience.